Welcome to Physical Science's Consultorium. This video is part of the series Misconceptions About Space, where we examine familiar ideas that feel intuitive but quietly need correction when physics is applied. In this episode, we ask a skeptical but important question: is dark matter just ignorance? Dark matter is often described as something scientists invented to explain what they do not understand. Because it cannot be seen directly, it is sometimes dismissed as a placeholder, a way of avoiding deeper problems in our theories. This skepticism feels reasonable. Dark matter does not emit light. It does not glow. It does not absorb radiation in any obvious way. If something cannot be seen, it is natural to question whether it exists at all. But in science, ignorance has a very specific character. It appears as confusion, inconsistency, and disagreement. Different observations point in different directions. No single explanation works reliably. Dark matter does not behave like that. The idea of dark matter emerged because many independent observations point to the same missing gravitational influence. These observations were not designed to support one idea. They came from different methods, instruments, and scales. One of the earliest clues came from how galaxies rotate. Stars far from the center move too fast to be held together by visible matter alone. This pattern appears repeatedly, across many galaxies. Another line of evidence comes from gravitational lensing. Light from distant objects bends more than visible matter can account for. The extra bending traces unseen mass, not uncertainty. On even larger scales, the distribution of galaxies across the universe shows structure that cannot form with ordinary matter alone. The same additional gravitational component is required again. These effects are not isolated. They reinforce each other. The same inference appears in galaxies, clusters, and the large-scale structure of the universe. This is not how ignorance behaves. Ignorance does not produce consistent, scale-independent patterns. It produces contradictions. Dark matter is therefore not defined by what it is made of. It is defined by what it does gravitationally, and by how reliably that behavior appears across observations. Importantly, dark matter is not a claim of final understanding. It is not a declaration that the problem is solved. It is a name given to a set of observed effects that demand explanation. Science often works this way. Phenomena are identified before their underlying nature is known. Names follow evidence, not certainty. Calling something dark matter does not mean we give up. It means this behavior is real, persistent, and constrained. Alternative explanations, such as modified gravity, are explored seriously. They are tested against the same evidence. Some succeed in limited cases, others fail elsewhere. This is part of normal scientific evaluation. The key point is classification. Dark matter is not ignorance. It is structured evidence awaiting deeper explanation. What remains unknown is its microscopic nature. What is well established is its gravitational role. Science separates these questions carefully. Knowing that something acts in a certain way is different from knowing what it is. This distinction allows progress without pretending to certainty. Dark matter is therefore not an excuse. It is a measured response to evidence that appears again and again, across independent observations. Understanding this difference helps clarify how science moves forward, by naming reliable patterns first, and explaining their deeper causes later. If this way of understanding space science is useful to you, this is exactly what Physical Science's Consultorium exists for. In this series, we examine intuitive claims and carefully reclassify them using physics. If you found this episode helpful, please like, share, and subscribe to the PSC channel.